In this video, I want to look at how to integrate everything that we've learned about graphing functions and rational functions to sketch the graph of a rational function. I want to take my time to do this, so we will only consider one example in this video. I want to sketch the graph of the following rational function. Now, it may be best to write this function in its factored form. The denominator factors into the linear factors x plus 5 and x plus 5. So let's compile some information about this function. First, what is the vertical asymptote? That's where the denominator equals 0. So x plus 5 equals 0 implies there is a vertical asymptote at x equals negative 5. To find the horizontal asymptote, consider the degree of the numerator and denominator. The degree of the numerator is less than that of the denominator, so that implies there is a horizontal asymptote at y equals 0. It would also be helpful to have a couple of particular points on this graph. We are often concerned about finding the x-intercept and the y-intercept. So we can find the x-intercept here by letting y equal 0 and solving for x. Now if you think about the scenario where we have this polynomial divided by another polynomial, I have this fraction and it's equal to 0, where does this occur? How could this fraction equal 0? Well, it's only going to occur if the numerator equals 0. The denominator can't equal 0, or the polynomial would be undefined. So we're going to say x minus 2 equals 0, or x equals 2. That means when y equals 0, x equals 2, and that is a point on the graph of this function. Now we can reverse that and find the y-intercept by plugging in x equals 0. We would get y equals 0 minus 2 over 0 squared plus 10 times 0 plus 25. This will give us negative 2 over 25. That's a very small number, very close to 0. So when x equals 0, y equals negative 2 over 25. So I'd like to just mark on the graph what I have observed so far. First, there's a vertical asymptote at x equals negative 5. So we can find that vertical line. We can show a dashed line there to represent a vertical asymptote. The graph is going to approach this line and the y values are going to go to positive or negative infinity. There's a horizontal asymptote at y equals 0. That's the same as the x-axis. So the x values are going to go to positive or negative infinity along this horizontal asymptote. And we found a couple of points. We found the point 2, 0, which raises an interesting point that a graph can actually cross a horizontal asymptote. So the y values are going to get closer and closer to 0 as x goes to infinity, and yet we are crossing the horizontal asymptote at this point 2, 0. And we could mark the y-intercept, 0, negative 2 over 25 is about right here. So I have a pretty good idea of how this function must behave because of the vertical and horizontal asymptotes. So for example here, I know that the graph crosses the horizontal asymptote at 2, 0, but because it's a horizontal asymptote, the y values must stay very close to 0 as x goes to infinity. And here, by the vertical asymptote, x equals negative 5, I'm expecting something like this pattern. I'm expecting the y values to go down to negative infinity. They can't be going to positive infinity here because I'm not crossing the x-axis again. so they must be extending to negative infinity. Over here in this region of the graph, I need to do a little bit of work to decide whether my values are positive or negative. So to fill in the rest of this picture, let's create a table of values with some different x values and then find the corresponding output values. It would be helpful for me to know what the behavior is like close to this vertical asymptote. So why don't we input the x value -4 and also input the x value -6. Those would be very helpful ones to know for this graph. Then I can sketch my graph with more reasonable accuracy. So when x equals -6, what is the y value? When x equals -6, y equals -8. What about when x equals -4? So when we input a value of -4, we get an output value of -6. Those additional 2 points help me sketch this graph with much more accuracy. So I can say the graph passes through the points -4, -6. That's about right here. And that actually corresponds pretty well to the picture that I drew. So I'm just going to fill in this dashed line. It looks like our function looks like this. On the right side, the y values are going down to -infinity, close to the vertical asymptote. We also know that the graph passes through the point -6, -8. So that's about right here. And that tells us how the function behaves on the left side of this asymptote. If it passes through -6, -8, the y values must be going down to -infinity here, and they must be approaching 0 here on the left. We could maybe plug in one more point to confirm this. Why don't we plug in the x value -8 and get a corresponding output value. At x equals -8, we get y equals -10/9. Here's x equals -8, -10/9 would be about right here. So I'm going to adjust my graph just a little bit to make it as accurate as possible, passing through -6, -8, and now passing through -8, -10/9. Here is a good sketch of our rational function, and we made this sketch using only algebra and a table of values.